All right, welcome to The Explainer. Today, we're going to decode something that's, well, absolutely crucial for making any software great, and that is test data.
Okay, so picture this. You've poured hours, maybe weeks, into building a new app. It looks great, the logic feels, flawless, but here's the real question. Is it unbreakable? What happens when a user does something you totally didn't see coming?
Well, that's exactly what we're going to dig into. We're going to pull back the curtain and really learn the secrets of how the pros do it, how they think, how they use a system to find and squash bugs before your users ever get a chance to.
All right, so before we get into the nitty-gritty of how to test, let's just take a step back and ask the big question. Why? Why do we even need to bother with this stuff? And it turns out, it really comes down to a core principle for building anything that you can actually rely on.
And the idea here is, it's really simple. Testing isn't some nice-to-have extra step. No way. It's literally the only way to prove that the thing you built actually does what you say it does. Think about it. It's the difference between hoping it works and knowing it works. It's all about building that confidence, that reliability.
And the main weapon in our arsenal for all of this, it's something called test data. Seriously, you can think of it like ammunition. It's what you load up and fire at your program to see if it can take the hit. It's every single little piece of info you intentionally feed into your app just to see what it does.
Okay, so we've got our mission. Where do we even begin? Well, you always start with the simplest, most optimistic scenario out there. We call it the happy path.
And the happy path uses something we call normal data. This is the kind of stuff you dream your users will enter. Perfect, predictable, totally by-the-book input. The whole point here is just to confirm that, when everything goes right, your program actually works the way you designed it to.
So, let's say you have a little program that averages test scores. Your normal test data would be something super simple, like a set of totally valid numbers. You feed it 50, 50, 50. You check that the result is 50, and bam, you've just proven the basic logic works. This is your baseline. It's simple, it's effective, and it's the perfect place to start.
But let's be honest. When are users ever that predictable? They make typos, they misread the instructions, they just get creative. And that's where our testing has to get a little more, shall we say, mischievous.
And this brings us to abnormal data. This is a huge shift in mindset. Your goal isn't to prove it works anymore. Now your goal is to prove it doesn't break. You are literally, intentionally trying to trip up your own program with data it's supposed to reject just to make sure it handles it with grace.
So, back to our grade averaging app. What happens if someone types in -12? Or, just types out the word 11? A brittle, fragile program. It might just crash and burn. But a robust one, it'll spot that invalid data, reject it, and hopefully give a useful error message. And proving that works is just as critical as getting the right average.
Okay, we've tested for the good stuff and the bad stuff. Now, let's push it. Let's test the absolute limit of what's allowed. It's time to live on the edge.
And this is where extreme data comes into play. If our app accepts scores from, say, 0 to 100, then our extreme data is, you guessed it, 0 and 100. These are the highest and lowest valid values possible. We're just checking to make sure the program doesn't trip up at the very, very ends of the scale.
But here's where it gets really interesting. There's a related, but much more subtle and powerful idea called boundary data. This is where so many bugs love to hide. It's not just about the limits themselves. It's about testing the values right on either side of that limit. The last good value and the first bad one.
Okay, so let's make this crystal clear. For our 0 to 100 scale, extreme data is just 0 and 100. Easy. But boundary data is more surgical. It tests -1 and 0, and then it tests 100 and 101. You have to prove that -1 gets rejected, but 0 gets accepted. And you have to prove that 100 gets accepted, but 101 gets rejected. That is how you know the line between right and wrong is drawn in exactly the right spot.
And this is the whole secret, right here. It's this methodical approach. You test the extremes, sure, 0 and 100, but then you zoom in and test those boundaries, checking that -1 fails and 0 passes.
This systematic way of poking at every single edge case, that's how you build a truly rock-solid system.
So, where does this leave us? What have we learned? Well, we've basically just put together a complete 4-part toolkit. And it's a toolkit that any developer, any tester can use to make their software dramatically better.
Let's run through it one last time. Our toolkit has 4 essential parts. First, normal data. Does it work? Second, abnormal data. Does it fail gracefully? Third, extreme data. Does it work at the limits? And finally, the most critical one, boundary data. Does it work right on the edge of the rules? You use all 4 of these, and you've basically covered all your bases.
And that brings us to a final question for you. Now that you've got the toolkit, which one of these, abnormal, extreme, or boundary, which type of error do you think gets missed the most? Especially by developers who are just trying to get the main feature working. Because it's usually in those forgotten little edges where the really nasty bugs are hiding. Thanks for joining me on The Explainer.